Slide 34 tells you now what it looks like. The 8.5 set of with the 8.5 Liberty profile, what do the offerings look like? So if you see, WAS for developers has a tools edition plus a Liberty profile. We have WAS which comes with Liberty profile along with tools edition. We have WAS Express which has a Liberty profile. So Liberty profile is being added into all the offerings because it's a lightweight version, very suitable for developers. But this is not to demean or undervalue the mainstream enterprise version of WAS. Now, in order to deploy into a production system, you really need the resiliency, the provisioning, the dynamic provisioning, the kind of tight operational control, the qualities of service which a professional and an enterprise class WAS brings, right? And that has its own importance. And what is important for a developer is to be able to take a subset of that runtime and which is suitable to his application, develop and be able to deploy onto the production system, a reliable production system with good fidelity between his development environment and the production environment. So this is what a developer wants. This is exactly what we give, because we have the Liberty profile that runs alongside WAS, and while the mainstream WAS, the enterprise class WAS works as a production environment, we have the Liberty profile that is a boon to the developers then. So together, they satisfy the needs of production as well as that of developers. Moving on to slide 35. Now let's take a quick look at the other features which fall under rapid application development. What we saw is the Liberty profile, which is great, excellent, and which is very good for developers desk. Now what is it that is making Liberty so fast, so seamless, so modular? Now there is the underlying technology which Liberty profile is using and which we also encourage our customers to use is OSGi. Now OSGi is not new. We have embraced it into the enterprise market a little over the time of WAS 7 feature pack, WAS 7 release and feature packs over that. But it has been existing with embedded systems for a long time for modular application development. We have a few slides here on OSGi which help understand the importance of OSGi and how it really is the cornerstone and foundation on which Liberty is running, and Liberty's success shows that OSGi is really important for product development and can really make the entire modules very structured, which will give a lot of performance gain, as you say in Liberty. 36, the slide number 36 gives an introduction of what OSGi is, right? Now, in slide 35, what is covered is the summary of OSGi, of the features of OSGi, which I'll be explaining in detail in slide 36 and so on, and then you will be able to get to the summary. So as you see in slide 36, right? Now this gives an introduction to what is OSGi, why is it so important? Now, if we take a step back to see what is exactly important to develop an application. Now, we all know that modular applications are important to develop because they're extensible, they're maintainable. And we rely on languages like object-oriented languages like Java, C, C++ to be able to do that for us. But if you see, there are some limitations to the packaging that we have here. The objects, as we know, are embedded in classes in packages. Packages are packaged into jars. Now, do we have jar scoped access modifiers? We have access modifiers at the level of class and below the jar kind of a structure, but at the jar level, do you have access modifiers? No, we don't. Do we have versioning at the level of jars? No, we don't. What is it that we face because of this? Now, when I have, say, a logging jar or a Xerxes jar that I have in my class path, and I want application A to use Xerxes 1.1 and application B to use Xerxes 1.2. How do I achieve this? There is no way, if I put it in the class path, I'm at the mercy of the class path. I do not know which application, when the class path will pick up which version in order to service which application. So application has no way of declaring its dependencies explicitly by version numbers of jars that it needs. Also, jars don't have versions attached to them in our traditional way of bundleizing and modularizing, right? That is where the modularization that we get using OSGi comes into picture and is very useful. Another classic example of where we fall short today is, suppose you need a specific logging jar or logging API or logging framework in an application. Now you are moving that application from development to production, or you have to, wherever you are deploying that application, or you have multiple applications that need the same jar. You have to bundle that jar several times. With each of the application, you have to keep bundling that jar. Logging jar. Logging jar is there in app A, in app B, in app C, in app D. Because there are, again, it comes down to the same thing, because there are no versions. If app A needs log4j1.1, app B needs log4j1.2, if you don't bundle them separate, individually, if you put it in the class path, you really don't know which is getting picked up. So in order to overcome all these problems we are seeing with traditional way of bundleizing and modularizing, OSGi comes into picture. If you go to slide 37, OSGi defines itself as a dynamic module system for Java. It introduces the concept of a bundle. A bundle is nothing but a jar with a specific manifest, bundle manifest, which has a bundle version, import package, export package. Now, if you see slowly the ills that got introduced in the earlier slide or because of the traditional way of bundleizing are all getting taken care of here. We have a bundle version, so we have the versioning problem sorted. Then we have import package and export package, by way of which a bundle is explicitly declaring its dependencies. So we have the other problem sorted, where we are actually doing multiple, copying the same jar multiple times in each application deployment. Because an application is, because a bundle is explicitly declaring its dependencies, the way OSGi runtime is made, there are several layers to it. The module layer, the bundle layer, the module layer, the lifecycle layer, the services layer. Now the lifecycle layer will not allow a bundle to start unless all its dependencies are reconciled alongside the dependencies of other bundles. So if all the imports and exports of this bundle are reconciled against the imports and exports of the other bundle, only then will this bundle be allowed to start. So you will not end up in class not found related kind of exceptions at a later point in time, because all of these are getting sorted at the time of bundling itself. So there's a whole host of good that OSGi brings along with it, and that's why I chose to actually expand on it. Alongside that, there is also there is no monolithic class path anymore. Like I said, you have each bundle that has its own class loader. So you don't have the hierarchical way of class loading right now. Each bundle has its own class loader, which